மேல தட்டிங் yeah okay see அப்புறமேயா சொல்லுங்க AlCl3 huh? AlCl3 may not be a good example because the moment you put AlCl3 in water, this will get hydrolyzed to form AlOH thrice and 3HCl. So I simply gave you AlCl3 because I wanted you to analyze a more reactive element. So better we will take something else like ZnSO4 aqueous. Okay. So what you should do is water aqueous lende two ions will come, which will be H plus and OH minus. And the electrolyte lende you will be getting Zn plus 2 and sulfate ion, correct?
Yes, ma'am.
Okay, so when you are subjecting it to electrolysis, we should consider the anode as a spot where oxidation will happen. And oxidation for what? Cation or anion? Who will get oxidized? Who will get oxidized? Loss of electron. Yeah, Prameya. Am I audible? Okay.
Yes,
minute,
ma'am.
One minute. 1 minute. Huh?
Ma'am, your net is breaking. No, you're frozen.
Now is it clear?
Yes, ma'am.
Yeah. Okay. So anode is the place where oxidation will happen or loss of electron will happen, right? Okay.
Yes, ma'am.
It's the next issue that in electrolysis, anode is positively charged. Okay. So
Yeah,
anode is
okay.
the place where oxidation will happen. Now my question is who will get oxidized? Cations or anions? SO4 2 minus and OH minus. Now I told you
Yeah.
certain rules. What were they? I told you,
At
no?
anode, the one with the lower anode will get
But I don't know.
oxidized.
But there was a star mark. What was that? Conditions.
Except for lower end.
A condition was what? Cl minus precedes over OH minus or
Oh,
water, which precedes over
yes, ma'am.
sulfate ion, carbonate ion, etc. Correct?
Yes, ma'am.
Okay. Apripata, who will get oxidized? Sulfate or
OH.
OH minus? OH minus, right? Now the problem is
Yeah.
what is the equation? Is the doubt about what is formed, what is getting oxidized, or what is the equation?
The no, I got which gets oxidized and which gets reduced.
Okay.
I didn't like. I didn't get the equation.
Sorry. இப்போ equationல oxygen is -2, hydrogen is +1. Out of the two, who will get oxidized?
Oxygen.
Oxygen only, no? 1 minute. I think Prajesh. Yeah. So this oxygen will become half an O2. Can we say that?
Yes, ma'am.
Okay. So what will happen to hydrogens? They will simply be there. You can put it as 2OH minus is becoming O2 and 2H plus also. Nothing wrong in that. Is that okay?
Okay. Yeah.
Equation is easy. Plus what?
Yeah.
There are two oxygens losing two
Two
electrons each. So 4 electrons will come out. You can write it with water also. You write it with water, you write it with OH, both are same. In which the O minus 2 only is becoming. So better to put it as O2, lose 4 electrons, and better to put it as 4H plus. Both the
Yes, ma'am.
equations are same.
Okay.
Any problem in this?
No, ma'am.
Okay. So this is the story at anode. At cathode, where the reduction. Who can get reduced, cations or anions?
Zn plus 2.
Or cathode in the electrolysis process is negatively charged. So
Yes, ma'am.
it will be either the H plus or the Zn plus 2. Now Zn plus 2 is above hydrogen in the reactivity series. So
Yeah.
it should have a negative E naught
Negative.
and
Yeah.
hydrogen is 0. Out of the two, what is the condition number 1?
Um, the H plus will get reduced.
Yeah. So H plus is getting reduced. Reduction means gain of electron. How much electron will you add? One positive, so one electron.
Yes, ma'am.
Okay. So since it is one electron, yeah. So since it is one electron, yes, Prajesh, we are doing products of electrolysis. Okay.
Yes, ma'am. Ma'am, I'm actually
Okay.
a bit off track, so it takes some time for me to
Yeah, I
get back.
understand. Okay. I have some recorded versions. I'll try to upload it and send it to you.
Yes, ma'am.
Okay.
Thank you.
Okay. So 2H plus 2 electrons gives H2. Is it okay? Aprameya, clear?
Yes, ma'am.
Okay. Take any other electrolyte. For example, let me try doing AgNO3, aqueous. So from aqueous comes H plus and OH minus. From the salt comes Ag plus and NO3 minus. So between H plus and Ag plus, who will get reduced?
H plus. Wait,
Illa.
sorry. Sorry.
Hydrogen
Plus Ag plus. Sorry.
the ones which are having, the ones which are present, copper, mercury,
Yeah,
silver, gold, and platinum
yeah.
will have positive values. So Ag plus will get reduced. So how many electrons depends upon the amount of charge. Ag
Yes.
plus will take one electron to form metallic Ag. And between OH and nitrate, who gets oxidized?
OH.
So take OH minus. Objective is that it should get oxidized. Again, this oxygen with negative charge only gets oxidized. So you'll put it as half O2 plus hydrogen is spectator plus 2 electrons are given out. You can
Yes,
put
ma'am.
it as 2OH minus gives O2 plus 2H plus 4 electrons. Got it?
Yes, ma'am.
Okay. Now, the problem, so the condition was what? The condition was the higher the E naught. I'll put it in the PPT so that it becomes, no? So higher the E naught, greater the reduction. Okay, this is at cathode. And at anode, lower the E naught, greater the oxidation. Also, there was some condition saying that chloride is better than water or OH minus, which is greater than all polyatomic ions like sulfate, carbonate, nitrate, etc. So these are the conditions. Now, let us go for some other substance. For example, H2SO4, or we'll put it as HCl. Shall we do? HCl
Okay.
dilute. So again, what are the ions that can reach cathode, which is negatively charged? This is
H plus.
electrolysis, and therefore the charge on the electrode will be opposite of the electrochemical cell. Anode, and the charge is positive. So cathode will receive H plus from both water as well as HCl, right?
Yes, ma'am.
Right?
Yes.
And anode, you will be Cl minus from the electrolyte and OH minus or water from the water itself. So between this and this, it makes no difference, no? H plus one electron becomes H or 2H plus because H atoms are unstable. So we'll put it as H2 gas. At the anode, who wins?
Fluorine.
That's all. So Cl minus should lose one electron because it is anode. Anode is the place where oxidation or loss of electron takes place. Cl minus loses one electron to form chlorine atom. Two such chlorides lose two electrons to form Cl2 gas. Clear?
Yeah, I understand.
Okay.
So the products of electrolysis will be the ones that have been oxidized and reduced, right?
Yes, obviously. Yes. It's not the question about what is. See, the question is not who will get oxidized. That is one part. Second part is what will it form? Generally, what
Okay.
will it form is the question. Who will get oxidized is the process.
So we can just add the cathode equation, anode equation, and then we'll get the product, right?
Yes.
Okay.
Okay. All these which we did now, they are all using platinum electrode, where the electrode does not participate. Now comes the next category where the electrode is also participating. For example, let us do it this way. I'm going to electrolyze copper chloride aqueous, or we'll put it this way, copper chloride molten, copper chloride molten, copper chloride aqueous using platinum, and copper chloride aqueous using copper electrode. Come on. So again, at cathode, at anode. Cathode, who will come? Cathode is negatively charged, anode is
Copper.
positively charged, copper. So Cu plus 2 ion will take 2 electrons to form copper. At anode, what will happen? It's chloride, or there is
Chlorine.
nobody else. It's nobody else. Now, Cl minus will remove one electron from itself to form Cl atom. Two chlorides will form Cl2. Okay. Okay. Supposing this were
Yes.
something like CaCl2, then at cathode, at anode, in molten state. Come on.
The same as above.
Same as above. Think about the metallic part. Yes. So Ca plus 2 is not going to compete with anybody because it is purely liquid. There is no water. So we get metallic copper and you will be getting the chlorine gas. Any doubt in this? 2Cl minus loses 2 electrons to form chlorine. Any doubt in this? Can I proceed to the next part?
Yes, ma'am.
Okay. The next, the moment it is aqueous, then at cathode, you will have Cu plus 2 competing with H plus. So the rule says what? The rule says higher the E naught, greater the ability to get reduced, greater the reduction. So out of the two, who has got a higher E naught value? What happened? Remember the
H plus.
reactivity series. Potassium, sodium, calcium,
Oh,
magnesium,
sorry.
aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, and platinum. So below hydrogen in the 10th reactivity series, whatever you learnt, their values are positive, and above hydrogen, they are all negative. So now the question is Cu or H plus, which will have a higher value?
See you.
And Cu should get reduced, na? So Cu2 plus, the one with a higher reduction potential value, will get reduced. Equation is clear? Any problem?
No, ma'am.
Okay. Coming to the anode. At anode, the two ions competing will be the chloride ion and the water, or the OH minus. Out of the two, who wins? We gave a condition here. Chloride is better than water or OH, which is better than sulfate, carbonate, nitrate. So which will get oxidized?
Chloride.
Chloride. So Cl minus, 2Cl minus would lose 2 electrons to form Cl2 gas. Okay, now comes the copper electrode. I'm going to take this to the next page. I need some space here. Okay, so copper chloride in copper electrode. Okay, aqueous again. So at cathode and at anode, the electrode is no longer inert. So the first thing that you will write is the metal itself, the electrode itself. Understood? The metal itself. Second thing, the other ions. So at cathode, the copper plus 2 or the H plus. At anode, the chloride or the OH minus. Clear? Clear?
Yes,
Three
ma'am.
ions, three things will compete. Okay, we can again narrow it down. How? Can a metal take electron get reduced to form Cu minus 1 or Cu minus 2?
No, ma'am.
So generally in the cathode you can remove this metal from the concentration because the metal rod will never undergo reduction. Clear? Less reactive or
Yes,
more reactive? Even less reactive, something like mercury. Can it become Hg minus 1 or minus 2?
No.
No. Can platinum, of course it is less reactive. Can it take electron and become platinum minus 1?
Ma'am, it's inert.
Never. So right from potassium, can any of the metal, can potassium take electron or lose electron?
Gain.
Potassium gains
Sorry, sorry.
2881 configuration.
Sorry, loses.
Loses. So even potassium loses because it is most reactive metal, and no metal will become negatively charged, even platinum. So nobody in this list will gain electron. So why to keep that here in competition? Understood?
Yes, ma'am.
Okay, but we have to consider it for anode. Now, when it comes to anode, so okay, cathode, between the two, therefore, copper is ruled out, the metal is ruled out. Between the two, who wins?
Cu2 plus.
Okay, so that will take two electrons to become copper metal, right? Now come to the anode. Okay, between your known items, what is known? Chloride and OH minus, who wins?
Chloride.
chloride.
Chloride. But what is the value for chloride? Remember, I told you a few things you should remember. Like for chloride, it is 1.36. For water, it is 1.23, which is enough. That's enough. Now come to the part. Between chloride and OH minus, there is a deviation. The one with the lesser value still does not get oxidized because of something called as over potential that we know. So out of the two, who wins? Chloride. That's an exception. We listed it out here. This is the extra wordings are for Prajesh. Prajesh at anode, the one with the lower E naught gets oxidized, but in spite of that, chloride with higher value gets oxidized than water. Is it okay, Prajesh?
Yes, ma'am.
That's because of the over potential required by the water. So the water will fail against chloride. Now, coming to between these two. Now, at the anode, the one with the lower E naught will get oxidized. Who has got lower E naught? Did we not learn that this is 0.34 volts? Yeah, tell me, between the two, who has got lower value? Chloride or copper?
Copper.
Copper.
Copper. So copper will get oxidized. What will it produce? Oxidation means what? Loss of electron. How many electrons can it lose generally?
2 electrons.
Two electrons to form what? Cu plus 2. Is that clear? The moment you introduce a reactive electrode, the electrode will participate, but not at cathode. It will participate only at anode. Understood this process?
Yes, ma'am.
First, you compare these two. This is known to us. Between chloride and OH, it is Li chloride. Then go for chloride and copper. Okay. Now, coming to the, let us say, AgNO3 using Ag. Come on, do it now. It is not an inert electrode unless you are given platinum. If it is platinum, inert. If it is anything else, then it is reactive.
Ma'am, the OH minus will form, will get reduced, oxidized, ma'am. OH minus will get oxidized.
Wait. Let us see. At anode, you have to include the reactive electrode and the now or between the three, which two are familiar to you?
OH minus and
NO3
NO3
minus.
Yeah. So between these two, OH minus will win. Now, once you know that, you know nitrate will not. Leave it. Go to Ag and OH minus. Now apply the logic. The one with the lower E naught will get oxidized. So who has got a lower E naught?
OH minus.
This is 0.80 volt. This is 1.23 volt.
Silver, ma'am.
So silver will get Ag will lose one electron to form Ag plus. At cathode, okay, the Ag, then Ag plus from the electrolyte and H plus from the water. Silver from the silver
Ignore
electrode.
AG.
So you can ignore Ag because they will never get reduced, right? Silver can never get reduced. Fine. Okay. Between Ag plus and Ag, at cathode, the one with the higher E naught. Who has got higher?
AG plus.
Ag. This is 0.80, this is 0. So Ag plus will take one electron to form Ag. So now see, look at this is clear?
Yes, ma'am.
Okay, I'm going to open the lesson because we will just look at one of the cases where this, no, where I can confidently apply. Below hydrogen, what are the metals that I see? This is inverse of the reactivity series that you studied. Remember, you started with potassium, sodium, calcium, magnesium in 10th standard, correct? But here it is ulta, na?
Yes, ma'am.
Correct? Okay. So I must find the hydrogen and below hydrogen. That means here above hydrogen. What are the metals? I must see the copper, mercury, silver. Where is silver? Silver, gold, and platinum is nowhere given. Platinum is not given, correct? Now look at it. So I usually compare what? Supposing it is chloride and copper. Chloride is 1.23, copper is 0.34 at anode. Who wins? The one with the lower value. Who wins?
Copper, ma'am.
Copper. If it is chloride, okay, and silver, who wins? 0.80.
Silver, ma'am.
Silver. If it is mercury, Hg, whose value is 0.92, who wins?
Mercury, ma'am.
Mercury. But if it is gold, whose value is 1.41, who wins?
Chloride ion, ma'am.
Chloride ion. Are you getting it? Ma ivlo deepa போய் கேட்கவே மாட்டாங்க ஏன்னா it will require memorization of this value, no, 1.41, 1.40, which is very difficult. Are we clear? So,
Yes.
below hydrogen, you have got copper, mercury, silver. We checked these three. Next is gold. Next is platinum. So, if it is gold or platinum, then it will be the chloride only which will undergo the oxidation, not gold or platinum. Obviously, they are less reactive. I'll put it in the perspective here. Supposing we are doing AuCl3 using AU electrode, dilute. What will happen? Again at cathode, you are going to look at, gold atom. Cathode is the place where reduction will happen. So Au, the metal will be included, the metal ion will be included, and from the dilute medium, H plus. Now tell me, can gold get reduced?
No, ma'am.
So remove it. Now between these two, we know that gold's position is what? In the reactivity series that you studied in class 10, it's below, na? Copper, mercury, silver, gold, and platinum. So obviously their values are positive. Who will get reduced between the two? Prameya, என்னாச்சு?
Ma'am, this silver.
It's gold, first of all, Ishan.
Yes, ma'am. Gold, ma'am.
Gold. So, cathode le gold will get reduced because its E0 value is higher than hydrogen. Hydrogen is 0. All others are positive values. Okay. Come to anode. Metal. Okay. Then chloride. Then water. So between these two, who wins? Known and unknown pola.
Chloride.
Chloride. Okay. இதோட value 1.23 volts. Gold ஓட value இப்பதான் பார்த்தோம் 1.40 volt. Anode la the one with the lower E0 gets oxidized. So who will get oxidized?
Chloride.
That shows that gold is a very, very inert metal. Gold, if gold is the case, gold oxidize agalena, can platinum get oxidized?
No.
That's all. Understood? Now
Yes,
you can take any of the cases. Say zinc or any metal like Fe. Fe, idella enna problem varona, they get hydrolyzed. Okay, they get hydrolyzed. Zinc also has got potential ability to get hydrolyzed. Supposing I'm doing magnesium chloride using magnesium, think about it. Cathode. Can I expect magnesium metal to get reduced?
No, ma'am.
So the other two are what? Mg plus 2 and H plus from the dilute water. Mg2 plus and Mg. So water lande H plus, MgCl2 lande Mg2 plus and Mg metal. Okay, these two. Now think about it. Out of the two, where is magnesium's position?
Hydrogen. This thing.
Above, na? All in the class 10 reactivity series. This is class 12 electrochemical series. Don't get confused between the two. In class 10 reactivity series, the elements on top will be found in the bottom side, but the values are negative. Below hydrogen, whatever you saw, their values will be positive, but in this table, they are found above. So don't, I'm referring to something that you've concretely studied in 10th standard. 10th la படிச்சிருப்போம். Potassium, sodium, calcium, magnesium, aluminium அப்படின்ட்டு. So I'm using that as reference. Okay. So that you can't go wrong. Okay. Then at anode. At anode, what will happen? At anode, who are the competitors?
Magnesium,
Cl minus,
and
water, and Mg. So think about it. This is 1.23 volt. This is definitely negative, na?
Yes, ma'am.
Oh, this is 1.36 and this is 1.23. But in spite of that, between the two, chloride wins, we know. Now the question is between magnesium and chloride, who will get oxidized? The rule says the one with the
Magnesium, ma'am.
lower E0. So magnesium will get oxidized. 2, magnesium will get oxidized. So magnesium loses 2 electrons to form Mg2 plus. Is that clear?
So, ma'am, if we supply electricity, this reaction will keep on continuously occurring.
You have to give raw material also, no?
Uh, Raw material, ma'am, but then in one side you have magnesium ion converting to magnesium, and the other magnesium converting to magnesium ion.
No, 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 no. At cathode, who gets reduced?
Hydrogen, yes, ma'am. Sorry, ma'am.
H2. Okay, so MgCl2, when you do it, you will get hydrogen at the cathode and Mg2 plus at the anode. Clear?
Yes, ma'am.
Hmm. Okay, even otherwise, see, supposing you are doing this is actually in class 10, you have studied electrolytic refining, na? Now think about that and you will understand it better. A thick, big rod of impure copper is taken as anode, remember?
Yes,
Impure
ma'am.
block, impure block of copper is taken as the anode. Okay, and a thin strip of pure copper is taken as the cathode. Both are made up of copper only. Okay, then current is this is made anode, so positive charge. This is made cathode, and they are dipped in aqueous copper sulfate. So aqueous copper sulfate provides you Cu2 plus H plus sulfate and the hydroxide or the water. Fine. Now,
Yes,
Ishan,
ma'am.
here is this perpetual? Think about it.
No, ma'am.
What will happen? See, assume that we'll put it this way. Instead of this, I'll put it this way. Now only you will understand this part actually. So these are copper atoms. The reddish brown metals are copper atoms. This is the impure copper block. Fine. And I have gold. This is gold. So I have a gold atom. Okay. And I have some, let us assume this one is the sodium atom. Some are potassiums or ions. So iron, this is iron. Is it okay?
Yes, ma'am.
Okay. So now see what is going to happen. This reddish brown is copper. This golden is gold. This was water, potassium, and the red was actually iron. Okay. So many. This is not going to be asked. Okay. Anyway, you would have complicated us. So, yaru keka matanga, but just for curiosity sake, we are doing. Okay. So I'm going to remove this so that I get some space to write. See again, cathode. What are the competitors? Cathode is the negative plate. Who will get?
Potassium, iron, gold, copper.
Wait. Cathode.
Yes, ma'am. Sorry.
Reduction. So Cu2 plus H plus and um, and the copper itself, the copper
Yes, ma'am.
rod itself. But we know that copper can never get oxidized. I mean, get never reduced.
Yes, ma'am.
Okay. So between the copper 2 plus and H plus, who will get reduced? The one with the higher value. This is 0 volt and
Copper,
this is
ma'am.
0.34. So there are lot of copper 2 plus ions in the solution because you took copper sulfate. The Cu2 plus will travel there and it will take 2 electrons and deposit itself as metallic copper. One copper atom gets attached to the surface. And progressively, when this happens, the cathode becomes thicker and thicker. Got it?
Yes, ma'am.
Deposition happens. Okay, come to the anode part. at anode which is positively charged, you will have many things to get oxidized. You've got potassium, iron, copper, and you have also got the sulfate and hydroxide or the water. Now think
Yes, ma'am.
about it. Who will get oxidized? The one with the least E naught value. Who has got the least E naught? Shall I show you the E naught table?
Potassium, ma'am.
Who has got the least E naught? Look at this. Potassium. This is only extrapolation, children. Okay, இது கேட்க போறதில்ல. So potassium gets oxidized. So K will become K plus and 1 electron. Fine. After the potassium is gone, this blue atom is gone. Okay, this blue atom is gone. That has come into the solution. After that, who will get oxidized?
Iron, man.
Iron. So iron is also getting oxidized to plus 2 electrons. Okay. After iron, who will get oxidized?
Copper, ma'am.
Copper. So one atom of copper, another atom of copper, another atom of copper will progressively keep dissolving out. The anode dissolves. Remember, anode dissolves and copper is converted to Cu plus 2. An equivalent amount of copper deposits. Remember the statement? When current is passed through, the copper atoms from the impure block dissolves into the solution to form Cu2 plus. An equivalent amount of Cu2 plus gets deposited. So copper migrates from the anode into the solution and the equivalent amount of it gets added. So the copper block will dissolve. Copper block will dissolve. Okay. And will get deposited here. So this cathode will become big and big and big. Okay. What will happen to the gold? Will gold get oxidized? There is gold
No,
also.
ma'am.
No way. So the atoms of gold will will do what you know? Will get collected in the bottom. What did you call this? The one which is
Yes.
the
Uh, the mud. Yes, ma'am.
anode mud. So the anode mud will usually contain the most precious metals because they could never get oxidized. Got it?
Yes, ma'am.
Also, one curious question. Copper got reduced, but why not potassium or a Fe2 plus? Can potassium ion or Fe2 plus get oxidized? I mean, can it get reduced? For reduction to happen, their E naught values should be higher, no?
Yes, ma'am.
But actually, they are very negative, no?
Yes, ma'am.
So, the more reactive impurities dissolve in the solution, the less reactive impurities settle down. From the impure block, copper gets oxidized, comes into the solution, and equivalent amount of copper gets deposited. Is this not the refining of copper itself?
Yes, ma'am. Copper sulfate turns some whitish color and it is not usable
Hmm.
because of this, ma'am.
Is that okay? Is that okay?
Yes, ma'am.
Okay, this part nobody is going to ask you. Is it okay? This part nobody is going to, this much nobody will ask you. If they ask you, it must be in MCQ section under HOTS. Is it okay? This much nobody asks. So I think that we have completed the entire lesson, correct? The last now the batteries are left out. Can I leave the batteries to you or you want me to do it? Okay, what will you do in batteries? I'll tell you. Okay, I'll anyway do it. Okay, we are going to go through. This is the last part. There was something called over potential. See, read this paragraph and read this. This was about NaCl aqueous. Is that okay?
Yes, ma'am.
Aprameya, is it fine?
Yes, ma'am. Do they ask the like this product of electrolysis in a like 5 mark or something? What
No,
is
no,
it?
no, no. Maximum
Oh,
it is asked in 1 mark.
oh, okay.
That's all. In fact,
They
we are
said
writing
1 mark,
so
so
much.
it's yeah.
No, we are writing so much. No, they will not ask you that much. They will simply say, what are the products? That's it. You have to quote the products. Supposing they say explain, they may add 1 more mark. That's all. Okay. Okay.
Yes, ma'am.
Okay. There are some exceptions. What are those exceptions? Supposing you are doing the electrolysis of dilute H2SO4, then we know at cathode the H plus will become H2, right? Because both water and the electrolyte is providing you with only H plus. So H plus has to get reduced. At anode, it's the sulfate against the water. Who wins, children, between these two?
Water.
Water. So water will form what? O2 plus 2H plus 2 electrons, correct?
Yes, ma'am.
Now imagine a situation where it is concentrated H2SO4. Then at cathode, no change. Same things will happen. Same things. But come to anode. Now tell me, who is more in amount? If it is concentrated H2SO4, who is more in amount? Sulfate is more or water is more?
Sulfate.
Then sulfate, does it have a problem in traveling and coming to the anode? It's very much
Yes, ma'am.
around the electrode itself, no? If this is the anode, then around the anode you find more sulfate than more water, na? Because it is concentrated sulfuric acid.
Yes, ma'am.
So, in such cases, sulfate gets oxidized. This is a rare case, a rare and exception. If it is concentrated sulfuric acid, the all throughout all these days, we were actually talking about who is more mobile, correct? Chloride is more mobile. So water shows over potential. Chloride quickly gets oxidized, even though its reduction potential is 1.23 volt. 1.36 volt, and water is 1.23 volt. Still, chloride is more mobile. Okay, water is more mobile than sulfate, so it can travel quickly to the anode and get oxidized. So compared to sulfate, water. Compared to water, chloride wins. Now, supposing you have got 1 lakh sulfates and 10 water molecules, then what will happen? Around
Sulfate
the
will
anode,
increase.
sulfate, what will happen in that case? SO4 2 minus will lose 2 electrons to form the S2O8 2 minus. Peroxodisulfate ion. Peroxodisulfate ion. Sulfur has S double bond O, double bond O. All this also they will not ask you. Structure. Only thing I am telling you. Here it is SOO. Do you see a peroxy link?
Yes, ma'am.
That's what is getting oxidized. This is all oxygens are in -2 state. These two oxygens are in -1. So the 2 electrons are actually coming from 2 of the oxygens, not from the sulfur. So this is a rarest of rare case in your textbook where if instead of dilute sulfuric acid it is concentrated, then at anode sulfate wins over water and sulfate gets oxidized to form peroxodisulfate ion. Clear?
Yes, ma'am.
Yes, Aprameya, is this concept clear? I don't want this slide to be done.
Yes, ma'am.
This is not required. Only
Okay.
this is very, very important. This is very important. Okay?
1 second, ma'am. Can you show this? Like 45.
Which one? Which one? This one.
No, no, 45.
45. This one. Yes, Prajesh, you are able to understand these?
Yes, ma'am. It's like a little here and there, but I get the context.
Okay. I have some recordings. I'll share it with you. You didn't come, so I also like no. There are some classes, class 12, some classes are there.
Yes, ma'am.
I'll try to share, okay?
Yes, ma'am.
Yeah, okay. Yeah. Is that fine, children? Can I proceed?
Yes, ma'am.
Okay. So I think from the textbook, all areas of questions we have done part by part. Clear? Check if anything is left out.
Just the batteries, I think.
Just the batteries is left out. This also we did. The best reducing agent will be the one with the most negative, but the metal has to be chosen. And the best oxidizing agent will be the one with the least E naught, but the ion will be chosen. Okay, so all these we have done. Molar conductivity problems, Faraday's law problems. This one. Look at this question 2.17. This is the what we did. So many cases we did, na? See?
Yes, ma'am.
Okay. Well, you have to watch silver electrode, platinum, platinum, platinum. What are you doing with what electrode? You must watch. Okay, this question is there. Okay, let us just quickly. I'll open one more time the book because I need the next lesson will be alcohols as discussed earlier, right? I hope your halogens have gone down well. You are comfortable, then we will proceed. So far, we have had only one test, correct?
Yes, ma'am.
Yes, ma'am. And
So
then
we
the
need
mini one that you get.
mini one I gave. So haloalkanes, haloarenes, we need to write a test.
Yes,
I'll
ma'am.
share question paper with you. Okay. Do please write and give. Otherwise, I will feel, what do you say? Like, no, I will start feeling guilty that I am not, unless I make you write the tests I evaluate, the process is not complete. Okay, it's
Ma'am,
very,
when will this test be? Uh,
I will send the question paper. It is up to you to take the test. Okay,
oh, okay.
yeah, I think this overlapping.
Ma'am, what mini test, ma'am?
I was asking, I will tell you, Ishan.
Yes, sir.
I'll tell you. Okay, I need to actually open the book. Okay, here itself I'll do. Why no? I want you to people to this one. Open the this page.
Reactivity, this thing, ma'am.
The E naught
Yes, ma'am.
value table. That is very important. So we will do it here. E naught table on one side because in exam they will provide you the E naught for such questions. Okay, for this question they will provide you the E naught, but here I don't have na. So I want you to parallelly have a look at it. Okay. Look at the question. Question says using the standard electrode potential given in the table. So we must look at the table. Okay. In the table, predict the reaction between the following, whether it is feasible or not. Feasible means whether it is going to happen or not. Okay. Whether it is going to happen or not. So let us write now. Fe plus 3 plus I minus. Now think about it. Okay. Now first thing first, you should predict what you can get. What you can get. What is possible for Fe3 plus? Oxidation or reduction?
Reduction.
Only because Fe can show Fe plus 2 or Fe plus 3, not more than that. So if you have Fe3 plus, you can't go to plus 4. But you can come down to Fe2 plus or Fe, right? Understood? So Fe can get reduction. Okay. So what will it form? Fe plus 2 or Fe? Okay. What can happen on I minus? If reduction is going on for this, what should happen for I minus? If this is undergoing reduction, what should happen? Oxidation. Again, ask yourself, can this undergo reduction? If you have a other thought, can I minus become I2 minus? So this has to get oxidized. If the reaction will be feasible only if the E naught of the reduction part is more than the E naught of the oxidation part. No, because if a reaction has to happen, then E naught of cathode minus E naught of anode, the E naught of cell should be positive. For a spontaneous process, E naught of cell should be positive, for which the E naught of cathode should be higher than E naught of anode. No, children.
Yes, ma'am.
Yes, ma'am.
So go and check what is the reduction potential for Fe3 plus to become Fe2 plus or Fe. Go and check. Fe3 plus to become Fe2 plus is how much?
0.77.
Okay, 0.77. I minus becoming I2. What is the reduction potential value?
0.54.
54. So is the condition satisfied? Is the reduction potential value of the reduction reaction greater than the reduction potential value of the oxidation reaction? Is it?
It's feasible.
It is feasible. 0.77 minus 0.54. Now one may have a question. I don't know. Ma'am, here the reaction is showing I2 becoming I minus, but you are writing I minus becoming I2. Are you getting that doubt? In the table, I2 is becoming I minus, but in my page, I am
There was
expecting
putting a
I.
minus.
No, we are not adding negative sign. We are not
Oh,
adding.
sorry.
What we are doing is, I told you many times, your ability to score marks will be compared with my ability to score marks. So since reduction is more feasible for Fe3 plus, oxidation is forced on the I minus to form I2. Don't ever change the sign of these values, no matter what reaction may occur. Don't change the signs. Have I told you this many times or not?
Yes, ma'am.
Don't ever change the sign. Even though, so the Fe3 plus is becoming Fe2 plus, reaction is given in that mode only. Fe3 plus is becoming Fe2 plus, no problem. Because this is getting reduced, the I minus is getting oxidized. But you will compare the 0.77 against 0.54 only. Don't change the sign to negative and all. Ma'am, I minus is becoming I2. Should I not take negative sign? No way. One's ability to score marks is compared against the other's ability to score marks, not the ulta. So always handle the reduction potential values with the sign given in the table. No matter whether it is undergoing oxidation or reduction. Clear? Clear? So the
Yes,
first one is feasible. Second one, again think about it. Ag plus and Cu. What can happen? Who can get oxidized? Who can get reduced? Can copper get reduced?
No, ma'am.
No way. So copper has to get oxidized. Cu plus 1 or Cu plus 2. What will happen to silver if this is getting oxidized? Then this must be getting reduced. So Ag metal Now what is the logic? The reduction potential value of the species undergoing reduction should be higher. Is it higher? This we know at least 0.80 and this is 0.34. Now tell me, will the reaction happen? Is the E naught for the species undergoing reduction higher than the species undergoing oxidation?
Yes, ma'am.
So the reaction will happen. Second is also possible. Okay. Yes, Prajesh, is it clear?
Yes, ma'am.
And Br minus. What can happen? What can happen to Br minus? Tell me. Can Br become Br minus 2?
No, ma'am.
No way. They are halogens. They have tendency to take only one electron. It's already there. It can't take one more. So this has to get oxidized. Again, those who have a doubt, how to identify oxidation? Apo, if my oxidation number is moving towards the right side, then it is oxidation. So it's -1 becoming 0. I'm moving from -1 to 0, oxidation. So this has to get reduced. What will it get reduced? It may form Fe2 plus or Fe. Go and check the value. The reduction part should be higher. Is it higher? Go and check. What is Fe3 plus becoming Fe? 0.77. What is Br minus becoming Br2 or Br2 becoming Br minus? Where is that? Br2 becoming Br minus 1.01. No matter whether it is oxidation or reduction, you will not change the sign. Now tell me, is this favorable? Is this favorable?
No,
No,
ma'am.
ma'am. No, ma'am. It's not favorable.
No, because the species undergoing reduction does not have a higher E naught value than the species undergoing oxidation. No reaction. Instead, by the way, if you had mixed Fe2 plus and Br2 in a container, then you would get these two. Agreed?
Yes, ma'am.
Because in reverse direction, this will become reduction and Fe2 plus becoming Fe3 plus would become oxidation. Nobody is asking you that, but simply just for knowledge sake, I'm telling. So forward is not possible, backward is possible. Okay, Aprameya, clear?
Yes, ma'am.
Think about the next one. Ag plus Fe plus 3.
Then it's not feasible.
Not feasible. Ag can get oxidized, correct?
Yes, ma'am. And Fe can get
A-
reduced.
and therefore Fe should get reduced. This is 0.80. This is 0.77. The reduction, the species undergoing reduction should have a higher E naught value, which is not there. So the reaction will not occur. Check the last one. This will not happen. This will not happen. Check the last one.
No, ma'am. It will not happen, ma'am.
Check that man Br2 and Fe plus 2. What can happen to Br2?
Reduce, ma'am.
Okay, Br minus, which is 1.09 volt.
Yes, ma'am.
Fe2 plus becoming Fe. What is the value?
2.87.
No, it is not. You are looking at something else.
Sorry, ma'am.
I
Sorry,
think
ma'am. Sorry, ma'am.
you are looking at F2, man.
Yes, ma'am. Look at chlorine, ma'am.
Okay. Now, where is that? Fe2 plus irka, inga irka.
minus 0.44.
It's minus 0.44. Minus 0.44. Okay. One bell should ring. Why? What bell you know? F2 is the best oxidizing agent with highest value. Can Fe2 plus be an oxidizing agent, man?
No, ma'am.
So here, this is undergoing reduction. This is undergoing oxidation. And the species getting reduced is having higher E naught. So the reaction should happen. And actually, just now, similar case we learned here. See? See?
Yes, ma'am.
Okay. Got it?
Yes, ma'am.
Okay. So these are the five like in the Mari, you can have many other predictions going on. Okay, what I would want you to do is go through the batteries once and come for the class next. Next class, I will tell you. I will be six. I have a schedule on that day. I told you last week itself, no? On Sunday. The 3rd, I will not be available, and from 17th to 22nd, I will not be available. So, we will have it on all Sundays, classes on all Sundays, barring this 21. Going to even next month also. Is it okay, children?
Yes, ma'am.
Some days, because I've come to Chennai, there are so many like work here where I have to go to doctors, I have to take people to doctors, all that is happening. So on 3rd, I'm not available. From 17th to 22nd morning only, I'm not available. I think 22nd evening, I'll be available. 21st night, I'm traveling back to Chennai. So 22nd will not be a problem. So I think 17th class and 19th class, I will not be able to take. Okay. So what we'll do is we will try to have the classes on all Sundays at 8 a.m. Is that okay? Up to
Yes, ma'am.
July end also. July end also. Okay. Going forward, mostly all Sundays we will have the class. Apart from Monday, Friday, Monday, Wednesday, and Friday. What about you, Prajesh? Are you available at 8 o'clock Sunday?
Mostly I'll be available, ma'am. If by any means I'm not available, I'll message early for the recording.
Okay. Okay. So this is so going forward July, June full, excepting 21st. Once I am going back to my place on 30th. After, July, there will not be any disturbance unless I am falling sick or something. Because only in Chennai we have got so many plans. Okay, a doctor visit or the relatives visit, family get together, this, that, and all. So once I go back, I'm going back on 30th to my place. Okay. So from July onwards, there will be no disturbance. Still, we will continue to have it on Sundays because we have missed some classes. Okay. Yes, children?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, ma. Okay. Yes. Homework. Homework is read the battery section. And we will meet on Friday. If I come back, because I don't think so, on 3rd, I'll be back. Okay. What about you people at 8 p.m. in the night, children? On that Wednesday, 8 or 8:30 p.m.
Ma'am, I have another
Okay. Because if 6 I'm not able to reach, I can delay the class. 8:30, you have a class, Prajesh?
from 7.
You are half audible. Okay. Then we will have it on Friday and then straight away on Sundays. Okay, ma. Yes, children.
Okay, ma'am.
Yes, ma.